Welcome to AlphaNumericTricks. Today we are going to see the problems under Z transform. Already we have some more problems. Then we see the second set of problems now. First problem, we have to find Z transform of r power n cos n theta. How will you find out Z transform of r power n cos n theta and Z transform of r power n sin n theta is? You have to using the term a is equal to r e power I theta. Using this relation, we have to find out is a transform of r power n cos n theta and r power n sin n theta. You know that is a transform of a power n is equal to, in the last video we saw that is a transform of a power n is equal to z by z minus a if mod z greater than a. Okay, this is the region of convergence. Now, is the transform of here we have to substitute r e power I theta. Instead of a, we are substituting r e power I theta whole power n. We have to substitute this. Okay, r e power I theta whole power n is equal to, in the place of a you have r e power I theta. So, z by z minus r e power I theta. In the place of a you have r e power I theta, that we have to substitute here. Okay, that is a transform of r into cos theta plus I sin theta. E part is e power I theta, cos theta plus I sin theta. We have to find out is the transform of this whole power n we have is equal to z by z minus r into e power I theta is cos theta plus I sin theta. You have to substitute. Okay. Next we have this term, that is the transform of n you have to take inside. So is the transform of n is common for this term also. Okay, so r power n into what is cos theta plus I sin theta whole power n, cos n theta plus I sin n theta. You have to substitute here cos n theta plus I sin n theta. That is, we have to substitute is equal to z by, you have to collect the real parts and imaginary parts, z minus r cos theta minus I into r sin theta. Okay, so or you can have this term is equal to here z by you have to collect the real parts together and the imaginary parts together, z minus r cos theta plus I into minus I into r sin theta or sin theta. You have to take conjugate and make the denominator to be real number. Okay, so we have to take the conjugate. As usual, no, that is denominator should not have a complex number, so we will make it to real number. So we have to take conjugate. Z into, what is conjugate of this term? Here you have to write this term to be z minus r cos theta. We are taking conjugate plus I r sin theta, okay, divided by z minus r cos theta minus I r sin theta into z minus r cos theta plus I r sin theta. Okay, this is the conjugate we are taking. So here we have to take this term here, z into z minus r cos theta minus plus I z r sin theta divided by, this is of the form a minus b into a plus b. So z minus r cos theta the whole squared plus r squared sin squared theta minus r sin theta plus I r sin theta, r squared sin squared theta, and the I squared you have, that is I into I plus I minus I you have minus I squared, but minus I value is equal to minus I squared value is equal to minus 1. So minus of minus 1 it becomes plus 1. That's why you have r squared sine squared theta you have. Okay. Or you have this term can be written as z into z minus z into z minus r cos theta plus I z r sin theta divided by, here you can write this term to be z squared minus 2z a plus a minus b the whole squared formula you have to apply. 2z r cos theta plus r squared cos squared theta plus r squared sin squared theta. You can write like this. R z into z minus r cos theta plus I z r sin theta divided by z squared minus 2zr cos theta. Here r squared is common, so take it outside, plus r squared into cos squared theta plus sin squared theta. What is cos squared theta plus sin squared theta, which is equal to 1. So you have to write like this, z into z minus r cos theta plus I z r sin theta divided by z square minus 2zr cos theta plus r square. This is the denominator we have. Okay, so what is your left hand side? Is it transform? Left hand side we have as, this is our left hand side, is a transform of r power n cos n theta plus r. This is the term we have, is a transform of r power n into cos n theta plus I sin n theta, isn't it? Now we have to compare the real parts. Comparing real and imaginary parts. Comparing real and imaginary parts, we have that is a transform of r power n cos n theta is equal to, here we are taking real parts alone, z into z minus r cos theta divided by z squared minus 2zr cos theta plus r squared. In the same way, imaginary part when we comparing r power n sin n theta. R power n sin n theta is equal to z r sin theta divided by z squared minus 2zr cos theta plus r squared. This is the z transform of cos n theta and z transform of r power n cos n theta and r power n sin n theta. And the condition for convergence here is always mod z is greater than modulus r. Because of this r, this condition should be satisfied. This is our region of convergence. Okay, so we get the result like this. This is your term. This is your z transform of r power n cos n theta, r power n sin theta. And using this, you can find out z transform the z transform of cos n theta and sin n theta. When you're substituting, r is equal to 1 here. Okay, when you substitute, when r is equal to 1. Next result, we have to prove that no is a transform of cos n theta. So when r is equal to 1, is a transform of cos n theta is equal to, put r is equal to 1 here. Okay, put r is equal to 1 in this formula. Okay, so we have is a transform of cos n theta is equal to z into z minus r is equal to 1 here divided by z squared minus 2z cos theta plus 1. R is equal to 1. So this is the value of z transform of cos n theta, and here mod z greater than 1. Region of convergence for this term is mod z greater than 1. Okay, in the same way, when you're substituting r is equal to 1 in this term, we get Z transform of sine n theta. Okay, when you're substituting Z transform of sine n theta is equal to, put r is equal to 1 here, okay, in the sine theta formula. So Z transform of sine n theta is equal to Z sine theta divided by Z squared minus 2Z cos theta plus 1 when mod Z is greater than 1. This is the Z transform of sine n theta. Okay, so this is the way you have to do it. And the next one, what is our next problem? Next problem is this 4 parts are over. Now we have to find out Z transform of 1 by n factorial and Z transform of a power n by n factorial. We will do it now. Z transform of 1 by n factorial first we will do. Okay, how will you find out Z transform of 1 by n factorial? We have to apply the formula here. Okay, so first you have to substitute the formula, write the formula. Z transform summation n is equal to 0 to infinity 1 by n factorial into Z power minus n. Okay, that is Z transform of f of n is equal to summation n is equal to 0 to infinity f of n Z power minus n. That formula we are using here. So which is equal to n is equal to 0, 1 to 3 substituted. Summation we are substituting n is equal to 1 value here. When you are substituting n is equal to 0, 1 by 0 factorial. What is 0 factorial? 0 factorial is equal to 1. So 1 into Z power n is equal to 0. Z power 0 is also 1 plus n is equal to 1 by 1 factorial Z power minus 1 plus 1 by 2 factorial Z power minus 2 plus etc. Okay, so which is equal to 1 plus 1 by Z into 1 by 1 factorial. Okay, 1 by Z into 1 by 1 factorial plus 1 by Z squared into 1 by 2 factorial plus etc. Or you can write this way, 1 plus 1 by 1 factorial into 1 by Z plus 1 by 2 factorial into 1 by Z squared plus etc. Okay, what is that expansion? This expansion is, what is e power x term expansion? E power x expansion is, expansion is 1 plus 1 by 1 factorial, 1 x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial plus etc. Okay, what about x here? In the place of x we have 1 by Z. X is equal to 1 by Z here. So e power 1 by Z is equal to 1 plus 1 by 1 factorial into 1 by Z plus 1 by 2 factorial into 1 by Z the whole square plus etc. Okay, so which is equal to e power 1 by Z. This is the Z transform of 1 by n factorial formula. E power 1 by Z. Okay, in the same way we have to find out Z transform of a power n by n factorial. As usual we have to apply the definition. Summation n is equal to 0 to infinity. F of n here is a power n by n factorial into Z power minus n. Okay, so here you have to expand the summation. Before expanding, you combine the terms. Okay, so 1 by, this term can be written as a power n can be written as that is a Z power minus 1 whole power n. You can write this now combining these two terms. A Z power minus 1 whole power n is a power n Z power minus n divided by n factorial. Now you substitute n is equal to 0. N is equal to 0, anything power 0 is 1 and 0 factorial is 1. So first term you have 1 plus n is equal to 1, you have a Z power minus 1 divided by 1 factorial. What about n is equal to 2? A Z power minus 1 the whole square divided by 2 factorial plus etc. up to infinity it will go. This is similar to your this expansion e power x, isn't it? So in the place of x you have a z power minus 1 is there. Okay, so this is equal to e power a z power minus 1, or you can write e power a z power minus 1 can be written as a by z. So z transform of a power n by n factorial is equal to e power a z. This is the value. Okay, so that's all for this video. If you have any doubts, please provide in the comment section. Thanks for your time and thanks for watching. We will have some more problems in the next video. Thank you.